Enceladus. It's a place in our solar system that has given us quite a lot of mysteries, wonders, and questions as far as scientific research and the exploration for life. From its fresh as fudge surface, its reflective as fudge body, and water vapor literally everywhere. So it clearly makes sense as to why we're going to look at it. I mean, let's be honest. And, well, after YouTube Analytics informed me that a 3-year-old video, conveniently titled with the exact same title as this video, but hopefully, was doing incredibly well and still getting consistent views for over 3 years, I figured it was either time to redo that video or purge it into the Shadow Realm, but clearly it's here, so clearly I didn't purge it. So, after a long absence, I decided to revisit the idea of colonizing planets. And so, as the beginning of doing the Can We Colonize series again, let's kick it off with the age-old question. Can we colonize Enceladus? Also, if you enjoy this kind of content and you want to see more of it, make sure to leave a like down below and comment if you want to see any other kinds of videos in the Can We Colonize series. I'm interested to do a lot of things like, Pluto. We don't talk about Pluto, but if you want to see more, comment it down below. But with that out of the way, let's get into the video. In order to determine if we can even colonize Enceladus in the first place, we're going to need to do a quick background check, and just kind of jot everything down that we know that may help our investigation in this matter. Let's start with some basics, and just kind of throw in some stuff here and there, so we know what we're working with. Enceladus is the 6th largest moon of Saturn, that glorious ringed planet that we all know and love. At least I hope you know and love it, I don't know. The planet is covered in a thick layer of fresh, fudging ice. This makes Enceladus the most reflective object in our solar system because it's fresh. Of course, that's not good if you're looking for a lady, am I right? Come on, boomers. Okay. On top of that, despite Enceladus actually being pretty small, believe it or not, sitting at just shy over 314 miles, it's actually the size of just shy of the United Kingdom. So, if you live in the UK, congratulations, there's a planet, or a moon, the size of your country. Represent. Its surface features, even though regardless of its size, are actually quite packed full. Why not check out the craters that litter the surface, because, moons and planets have craters, or the smooth plains on its surface, or maybe the mysterious rivers that aren't actually rivers, you know what I mean? Plumes of water vapor, along with common materials that you'll find in things like comets as well as other celestial bodies, jet out from geysers surrounding the entire surface of Enceladus. Fun fact, actually, did you know that these geysers actually form parts of Saturn's rings? Kind of an interesting one, don't you think? It's also stated that while Enceladus' interior is actually quite liquid-like, which I'll get to in a bit later on, it's actually stated that it should be a frozen ball, and that it should have done that a very long time ago. But hold on to that though, because it's gonna get better. Fun fact, Enceladus, after a lot of research and discoveries and evidence found in the late 2000s as well as the early 2010s, it actually has a subsurface ocean. What that basically means is it's an ocean, but it's underneath the surface of the planet. So imagine, digging down into Earth 100 miles, you find a ocean that surrounds the entire planet. That's essentially what a subsurface ocean is. This indicated that water does exist on Enceladus, which is a very big deal. The only issue with this, however, is that it's just very salty. The reason this ocean even exists is actually because of a process that's called libration. This process occurs actually because Enceladus wobbles while it orbits, both around Saturn, and it also does that because of the other moons that it orbits, like Dione, for example. This also makes that Enceladus' orbit is in an elliptical orbit, which basically just means that it's not in a circular orbit, and that its orbit is a bit weird. It might be farther out from in one place than it might be in the other place. A good example of an elliptical orbit would be here, where a planet or a moon might swoop into its star at a fast pace and then get jetted out. An elliptical orbit works in the same fashion. So therefore, in this instance, you can kind of think of the icy crust of Enceladus, while being there. Imagine it kind of floating, essentially, on a giant ocean-wide layer beneath that. The ocean itself sits around 15 to 20 miles deep, or for you British folks who don't use miles, about 25 to 35 kilometers deep, which is actually quite impressive considering how small Enceladus actually is. To put that into context, Earth's oceans, in this case on our own planet, have an average depth of only around 3.7 kilometers, or 2.3 miles, which should give you an idea of just how big the oceans are on Enceladus, but bear in mind, Enceladus is a lot smaller than Earth, so to us, it's gonna feel relatively the same as if we're traveling, 20 miles. Note that this ocean is pretty salty, and you can definitely tell this from the plumes that eject out from the Enceladus' surface. This is because the plumes actually contain things, like ammonia and hydrogen, but also things like sodium and carbon trioxide. Moving on, let's talk about some heat. Enceladus has got to have some heat somewhere, right? Whether that be in its core or its poles or something like that. Well, turns out it is heated. Sort of, we'll put it. Directly on the north and south poles, the core of Enceladus actually heats up the poles. But bear in mind, it's not, like 2 degrees Fahrenheit over there. No, it's still 115 degrees Celsius. So don't think it's summer over there. Just don't think that. There's also the effects of tidal heating, whether that be through things like tidal locked forces, like we have here on Earth with tectonic plates, or through tidal heating through just through Enceladus' core's crust and mantle as a whole. Libration can actually help play a factor into how Enceladus can use tidal heating to heat up, but it's a bit complicated, so I won't go into it. There's also the use of radioactive heating that Enceladus can use to heat itself, through the use of things like radioactive isotopes. These things can include things like uranium-238, 235, or thorium-232 or potassium-40, as well as many other radioactive isotopes. Now, bear in mind, some isotopes might heat better than others, and some are better conductors than many others. They at least do something, but most of them aren't going to contribute to a mass increase of the temperature on Enceladus. But at least it does something. Now let's move to the other side, though. Can we make Enceladus habitable? What I mean by habitable is, can we safely put a human colony on Enceladus to live there indefinitely? Can we put, say, the state of Texas, well, not the state of Texas, but let's just say we put the state of Texas, hypothetically, on Enceladus? Could they survive? And would there be problems? Could they breathe? Could they get water? Could they get food? Could animals survive there? Well, now that we got some information, let's start putting it together, and let's just see how it works. Let's start with the plumes as well as the subsurface ocean, because that's going to help us here. Let's recall that Enceladus ejects plumes of primarily salted water. Those plumes are also laced with grains of silica-rich sand, which is basically sand enriched in silicon. It also pumps out pockets of nitrogen that are inside ammonia molecules, as well as organic molecules. Those molecules can have traces of basic hydrocarbons. Those things include things like methane, propane, and even formaldehyde. These are all carbon-bearing molecules, and especially for someone who focuses on things like science and biology, carbon-based molecules are what things that help make life on Earth, happen. This actually does help in our case, though, because it does confirm that there is some kind of hydrothermal activity going on in Enceladus' oceans, which will help later in the line, whether that be for marine life or human life. Over the course of time, after some research and discoveries made by several pass-bys over Enceladus, we actually confirmed that its rocky core is what's called porous. This basically just means that water can safely flow right through the planet's core, carrying both heat as well as chemicals along with it, which explains why Enceladus' core is very liquid-like and not frozen, but there might be more to this explanation, so we'll have to wait and see. Hydrogen, a major part of life that creates life here on Earth, can actually be metabolized via methanogen microbes, which are microbes that help take in hydrogen and be able to produce energy for life forms. It's not exactly sure if that's present on Enceladus right now, but we don't want to leave out these details though, because they're a big deal in the grand scheme of things, so just bear that in mind. But note that since all these reactions are happening, it's also technically likely to consider that reactions similar to on Earth, how we have water and rock reactions happening here on Earth, they might be similar to that on Enceladus. So maybe molecular reactions on both of our worlds are technically similar, which is a big deal. Later on, in 2017, we also found the possibility of hydrothermal activities on the ocean floors of Enceladus, hence why we're talking about it. And after a lot of months of research, dedication, and work, we determined that hydrogen was the most likely candidate as to what was causing that hydrothermal activity. It's also been speculated that that might hint to an oasis of habitability, since, well, there might be life down there, and that gives enough molecules and the basics for life to form in the oceans. But then again, it might just be in the oceans of Enceladus, not on the surface, since we're only talking about the oceans here. But let's move away from the oceans of Enceladus and the gas plumes, and let's focus on the atmosphere, which is, well, literally made of water. Now, hear me out. Enceladus does have an atmosphere. It might be hard to see at first, but it does have an atmosphere. However, its primary ingredient is made of 91% water vapor. Although it's actually kind of surprising if you think about it, considering how far away we are from the sun, and I would assume that the farther away you get, either you'll have an atmosphere or you won't, but if you do have an atmosphere, it's made of weird elements. In this case, maybe like Titan with methane and carbon, and in this case with Enceladus with water vapor. However, that doesn't mean that the entire atmosphere is made of water. There are still things like nitrogen and carbon though, so that's a plus, I guess. So, if we're going to colonize Enceladus, I think the first thing we would need to do is fix the atmosphere. And, well, artificially modifying an atmosphere is not as easy as it might sound. There's a lot of steps that have to go in to make that work. So, what could we do? Well, number one is we could use other celestial bodies. For instance, we could take things from other celestial bodies like comets and bring them to Enceladus. This, in the long run, might help with the overall atmosphere, bringing new elements in, or reusing other elements that the atmosphere has never seen before. Or maybe using things like nitrogen and carbon, which are already present in Enceladus' atmosphere, and just raising up the numbers and seeing what that does. Obviously, there's no oxygen in Enceladus' atmosphere, so breathing is kind of a problem. So we would need machinery that could produce oxygen, or something that could pump enough oxygen into the atmosphere for us to breathe. As well as some nitrogen, because even Earth's own atmosphere is 78% nitrogen, so unless if that plays a factor, I'm not entirely sure, but nitrogen definitely seems like a good point. The other option is we can just kind of use what we have on Enceladus. The problem with that, however, is, well, it's already confirmed, by the most part, that Enceladus doesn't contain oxygen. It's primarily just an ice ball with water. So I don't know how you're going to get oxygen, but we can try to use the existing stuff that's already on Enceladus to create life. But bear in mind, there might already be life there, we just don't know it yet. Again, terraforming an atmosphere is not an easy task. It can take up to decades or even centuries to complete because it's very long. But bear in mind that we're also dealing with a small object here around the size of the United Kingdom. So, therefore, it's not going to take as long as something like, say, terraforming Mars' atmosphere was. Since Mars is a much bigger object than Enceladus, it's going to take longer. Enceladus is smaller, so it takes less time, but regardless, it's still going to take time. So, this is something that would need to be worked on. But what about the surface of Enceladus? Because we haven't really touched on that. While, yes, granted, we're only dealing with a planet or a moon about the size of the United Kingdom at over 300 miles, it's all just ice. Very slippery ice. And if it isn't ice, then it's most likely going to be maybe wet, cold ground. So building structures on Enceladus might be a bit of a challenge, especially with the cold combined with the ice. Now, yes, there is that ocean that's under the moon's crust, so technically you could probably go in deeper, maybe build stuff in the water perhaps, but bear in mind that's not necessarily a surface. It's just going to make it harder, and combined with the fact that these oceans are miles and miles deep, I'm pretty positive that's probably not a good idea. Flat Earthers, don't come at me thinking that you can build on water. Please don't. There's also a lot of other factors that we have to factor in here. Solar flares, something that can come at both Earth, Mars, Venus, pretty much any planet in the inner solar system, are ejected from the sun. They have the power to increase the temperature on Earth temporarily and knock out power lines as well as communications. Solar flares can still reach planets like Saturn, as well as Enceladus and many other moons far out into the solar system. So we're gonna need something to help try and deflect some of those flares. For Earth, we have our magnetic field. While in this case, Earth does do a pretty good job of deflecting it, it's not perfect. Yes, we still have communication errors, yes, that's that, because magnetic fields just can't hold entirely the entire strength. However, Enceladus doesn't necessarily have that great of a magnetic field, or it doesn't have one. Now yes, technically we can artificially make magnetic fields, or we can strengthen one that's already there. However, it's not going to be perfect, especially if we're on something like a deadline, if one's on the way, or if it's just for safety in general. In this case, similar to the atmosphere problem from earlier, would take a lot of time. Whether that be decades or centuries, or just a few years, at this point it would be very costly to do so. So in the end, it's not really the best option. More importantly, it's cold. Enceladus is not the kind of planet that's as close as Earth, because Saturn's a bit of a ways out. It's actually well under 300 degrees Fahrenheit, or under I said that wrong, under negative 300 degrees Fahrenheit, or in this case for Celsius, negative 150 degrees Celsius. So it's pretty cold over there. So in that case, how do you fix cold? Well, if you're someone who's been focused on things like climate change, as well as things like how to decrease the things like coal production, as well as oil burning, you'll probably heard of something called the greenhouse effect. Here on Earth, whenever we burn things with fossil fuels, in this case like gas, oil, and coal, we're producing smoke, and carbon dioxide that goes into the atmosphere, which ever so slowly heats up the planet. In this case, we can basically do the exact same thing for Enceladus. Therefore, by increasing the greenhouse effect by pumping gases such as carbon dioxide via the burning of things like coal, oil, and gas, we can ever so slowly increase the greenhouse temperature on the planet. Again, that's still going to take decades or centuries to get to a stable level. But there's also the factor of there's not really no way of telling as to how long that's going to stay after we stop producing it. For instance, if we were to go for, say, 100 years and the temperature went up, let's say, 50 degrees, there's no telling how fast that 50 degrees is going to go shoot back down again. It might disappear instantly, it might disappear within a few years, so it's unknown if we would have to keep producing fossil fuels and the burning of fossil fuels as a whole to keep the planet from freezing. So that's a bit of an interesting thought. So what is my final verdict in this situation? In my opinion, after the many reasons I've stated, I just don't think it's possible to colonize Enceladus. Both because it would be wickedly expensive, and we'd probably have to take loans out of the many countries on the planet, and the many challenges that we'd have to overcome. For one, we'd need to increase the greenhouse effect to heat Enceladus, and we would also need to strengthen the atmosphere with both new and different elements in order to breathe safely. While yes, we can increase the greenhouse effect safely on Earth, there's no telling how that's going to fare on Enceladus, both with its atmosphere and how much it's going to contain within itself, and how long that will take. The same thing goes for the atmosphere. It'll just take too long. Building structures on ice or just cold surfaces wouldn't really work that well, and especially for factoring in things like sewer systems and underground systems like railways and tunnels, it's not going to be that great. We're not entirely sure how long the crust goes leading down to the subsurface oceans, so for all we know it could be 5 miles, and at that point, it's debatable. So therefore, building underground systems might not be best. The planet's also really small. Now, granted, it is the size of the United Kingdom, but assuming we could colonize Enceladus, it's gonna fill up relatively quickly. At this point, it would just be more like a resort hotel than it would be a new home for humanity, and at that point, you'd rather just go to Mars because Mars is bigger. But, again, when you factor how much time that's going to take, decades or centuries, or even millennia for that matter, and it would be wasting billions upon billions of dollars, who knows, from multiple countries, and probably putting the planet itself in debt. So, could we colonize Enceladus? Probably not. Unless we were completely insane as a race and were willing to spend ridiculous amounts of money to make that happen. However, I wouldn't give it a bad eye that there might be life on Enceladus already. I mentioned that subsurface ocean, how there is molecules down there to make life possible. So maybe there is marine life down on the subsurface ocean of Enceladus. Perhaps we just can't find it yet. And if there is, I mean, come on. I'd love to live there. It's relatively deep, so you can swim all to your heart's content. There's hydrothermal activity down there, so there's new molecules breathing in, so it's not like you're just eating things that are like 2,000 years old. And it's nice and quiet, free from the problems that we're enduring on Earth right now, whether that be current pandemics, weird government agencies, and furthermore, it'd be a nice place to live. Therefore, gentlemen, I rest my case. That is my case on why we cannot colonize Enceladus. Questions? Yeah, can you repeat that again? I actually didn't get most of it, if that's okay with you. Oh, for God's sake.